Hello, everyone. This is a review of the current state of the P extension and where we're at with it, and some of an overview of what the POC SIMD can offer for the programming world and for the advances in our industry. So the Scalar SIMD, single instruction, multiple data, signal processing instructions serve a specialized and important use in modern day technologies, and there's really two main areas. There's the, see if I can zoom this in, nope. Effective signal processing and, well, that's hard to read. Performance and latency critical areas. Okay, so there's latency critical and other, okay, so we already covered critical deterministic execution, while Scalar SIMD can help achieve more efficient than full SIMD or GPU offloading. So you have saturating arithmetic, so there's no, avoids overflow. You have multiply and accumulate instructions, you have bit manipulation instructions. And you have the fixed point math. So these reduce the number of cycles that are needed to do the application. So they're latency critical and often require deterministic execution, which Scalar SIMD may help achieve more effectively than full vector, as I said earlier. And some of these areas are related to filtering and FFTs and image and audio codecs and AI/ML operations with the neural networks. So for reduced power, you definitely have reduced power and area in these systems. So for the embedded IoT devices, as a data point in an Andes high-end core with out-of-order dual issue, the SIMD, I'm sorry, the VSpec, the VPU is roughly 800K gates, and the POC SIMD is about 86K gates. So there's quite a bit of difference in the performance, in the size of the units, and the Scalar SIMD offers a middle ground, moderating parallelism with small energy and area budgets. Then there's also legacy and real-time software acceleration. Many legacy DSP applications written in assembly or tight C code or scalar in structure, and these instructions allow these to run faster on general purpose CPUs without full characterization or massive code rewrite. And markets that benefit from this type of work, well, we have the mobile and the edge AI with audio and imaging pre-processing, sensor fusion, always on AI tasks like keyword spotting, low res, face detection, and efficient handling of quantized neural networks with Int 8 and Int 16. I think I skipped ahead on a slide. No. Then for the automotive and in the industrial IoT, you've got real-time control systems. You have radar and LiDAR data processing. You have vibration monitoring. You have functional safety applications that demand determinism and reliability. Consumer electronics, well, you all have definitely heard the audio DSPs in your speakers, headphones, noise cancellation, echo reduction, image enhancements in cameras, gesture recognition in gaming devices or smart TVs, It's also heavily involved with communication with 5G satellite and radio, with channel encoding and decoding, modulation, demodulation, and packet processing. And then with the embedded in the microcontroller markets, you can see their use, and you can see its use in hearing aids, fitness bands, smartwatches, and the like. Okay, don't want to go there yet. Well, yeah, we can go there. There are several parts, sorry for my tripping over my words here, that are currently located in different places because multiple people have been working on the different parts. We have the new RV32 paired instructions that was written up in one area. We have the old V0.92 spec where most of the instructions have come out of with mnemonic changes. And there's been work also done by John Hauser and the team to come up with the latest rounds of instructions and opcodes. And we're currently right now, we started a discussion with the ARC a couple of weeks ago about how a complex and big ISA spec with hundreds of instructions, what that should look like and how it should be presented to people and what information is needed. So you've got the opcodes, you've got the syntax, you've got the functional descriptions, you have the sale code for the implementation of the instruction, and then you have the intrinsic functions for C and for C++ for people to use. And we're expecting to have the first draft pulled together pretty much in the next month. Tool-wise and update-wise on the ecosystem, GCC LLVM and binutils, GDB work has been done. The majority of that's been pushed into upstream projects. The C++ intrinsic functions are currently under development and will also be pushed to the repos. The sale code, the ACTs, and RISC-V work will reside in the GitHub P extension repo, and we have Quemu and Spike work that's currently under test at this point in time. So for benchmarking, this is audio and codecs specifically. I showed cycle counts because for timing budget-wise, for many people, they're more concerned about cycle counts than they are in actual speed-ups. The smaller red numbers are with the DSP, so you can see how much faster the DSP accelerated code is for these codecs. And this is both audio and video codecs. And unfortunately, there was a bunch of AIML slides I wanted to include in the presentation, but it didn't work out well because we really wanted to focus on the fact that DSP and SIMD, PAC SIMD, is more than audio codecs. It can be used in neural networks and other DSP applications. And for example, for the CM sys-NNN APIs, we support 8 categories of functions. We support the activation, basic, concatenation, convolution, fully connected, pooling, softmax, and the utils. And we get, depending on which core you're using of ours, we get from a 9 to 16x improvement overall on those libraries. And then in the some of the, and then related areas, we can do the face detection work with PNet, which is roughly a 10x improvement. We can do image classification with the CIFR10 databases, and that's about a 14x performance improvement. And that's about all I had for those improvements. And I think I sped through that way too fast. That's all I had.
Just means you have more time for questions, Rich.
Just have barely enough time?
No, you have more time.
Oh, I really?
Sure.
How much more time do I have?
Well, it's like a sale. The more you spend, the more you save, right? The faster you talk, the more time you have left. No, seriously, do you want to take questions? You have time for questions?
I have a few, but
Okay.
I might need to give people my business cards so I can get a more complete answer to them.
There are no promises. Let's go up here. David does promise to be nice, though.
Does he? Please, David.
Hi, Rich. That was very interesting to get a 14x speed up. Can you say anything about the number of parallel lanes in the SIMD unit that's giving such a tremendous speed up?
Well, for the 8-bit data with RV64, you got 8 parallel lanes. And for 16 bits, you got 4. RV32 is going to be half of those numbers. But the big speed ups are on the int date.
Can you give a little intuition of
No, I
why
have
we
to
get
get
such a
back.
speed up?
I can get back to you on that. I'll give you my card.
Thank you.
Yeah, and you mentioned that we had the problem with the slides. Are you going to upload a version of the slides with the extra information in it to SCED?
Yes.
Okay, so people who are interested in things Rich talked about, check the SCED tool. He will have the slides there.
Yeah,
so
early
people
in
can
the
see
week,
it.
and I'll have the PDF and the slides.
Okay, thank you.
Hi, just a quick question. The SIMD instructions currently proposed, they only use the integer register map, or can you do SIMD on floating point as well?
No, it's only on integer, and that's one of the big pluses for the size, the area reduction, because it's integer reds only. There has been discussions in other groups about SIMD with the FP units, but we're not really looking at that at this point. We're keeping track of it, but not really focused on it.
Okay. Any more? Oh, here we go. Nicholas?
Oh no, not Nicholas.
No, just a quick question. How stable is the current state of the P extension? Do you expect any big changes with the IRC discussion, or is it?
No, I think we're in good shape because we have an advocate from the ARC who's been working with us and with naming conventions and opcodes and all the rest of it. So I think we're going to be in pretty good shape. We have, and with the sale code already implemented for everything, we know that the instructions are working as defined. There may be some, who knows? I mean, this is only a preliminary, and the ARC always reminds me not to say it's a draft. It reminds me to remind everybody it can change at any time. So we'll see how that goes.
All right, one more question. Anybody want to be the final question? If not, we'll give Rich a big round of applause. Let's thank him.